estimation. So kernel density estimation is a non-parametric way to estimate the probability density function. Now you can also find out the probability density function using a parametric technique, but you can also do that using non-parametric way. Okay, and kernel density estimation, also known as KDE, is one such way in which you can find the probability density function. It's also used for smoothing purpose, right? If you want to smooth the data and want to plot the data with some sort of a smoothing, then you can also use kernel density estimation. It's also quite useful in exploratory data analysis. So if you want to understand the distribution of the data and just want to make it look okay, just without yeah, without giving importance to the unsmooth section of the data, then kernel density estimation is a very good way. Actually, it smoothens a bit and you have control over how you can smooth, right? There's some default way in which you can do, but you can also choose your smoothing parameters. You want to smooth more, you smooth less, up to you. But what's most important to understand is that it's a non-parametric way. That means you're not fitting a model here. You're not fitting some sort of a regression line here to find out these estimates. It's a non-parametric way. Okay, it's more like your k-means algorithm, similar sort of an algorithm, this one. Okay, so we'll take a data set. We have used this data set in many of my videos. Is the empty cars. So let me show you what's in there. So you have a lot of field related to cars, and the variable of interest is the mileage here. Okay, it's mileage of the car, and we like to plot the kernel density for this particular field. Okay, so before that, let's plot the histogram of it, because histogram is also quite similar to the kernel density estimation. uh, in fact, kernel density estimation is a smooth version of histogram, right, to put it differently. Okay, so here here you have the histogram looks like. You have yeah, but the one big difference between histogram and the probability density function using KDE is that in the y-axis you get the percentage, right? And the area under that is 1. Whereas here in histogram you just have number, right? So difference is that okay, there are 4 cases, 4 vehicles or 4 cars that has a mileage between 10 to 15 kilometer. Okay, and when you take the percentage of the entire population, then it's basically your probability density function. It's as simple as that. It's quite relatable actually. Histogram and the KDE plot are quite similar. Okay, and how do we do it? Well, we can also use a function in R. So here the function used is density. There's no other thing there actually, right? It's just density and provide the name of the field. And in R, we actually provide first the data set name and then the field name separated by a dollar, right? So here you have, I'm storing the output of this particular, yeah. So when you use density, it probably actually, what it does is that it will give us the values, but it won't actually plot. You have to use a plot function to plot that. Okay, this is how we're done. We're storing it in a variable D, and then we're plotting it. Okay, so let us run this. So when you run this, you get this particular plot, which is smooth version, right? Smoother than even the histogram. And as I said, in the y-axis, you see these are fractions, right? And we take the area under this curve, it is always going to be 1. And that's the property of a probability density function, where the area under it is always 1, right? Okay. You can also fill in. We can also have a more shadowed version of the plot. Same syntax, it's just that we use this polygon function, where sometimes for reporting purpose you need to shed it on the area under that, just to be clear as to what we mean by area under that particular curve. So we can also fill it in. Okay, so here I've used red color. You can choose any other color here. Okay, so remember this function polygon, and you will get a shaded version of the same plot. We have a dedicated R package also for that. It's called the k density, and you have a lot more flexibility there. In density, this the one that comes by default when you install R. It doesn't have much options. As I said previously, you cannot just have the probability density function. You can also smooth your data, and for smoothing you might want to change the smoothing parameter once in a while, and sometimes you might even want to use some parametric way of having the probability density function, not just unparametric. And how about having a dedicated function, a dedicated package for that? And R does have such a package where you have a lot more flexibility when it comes to choosing, whether you want non-parametric or parametric, what is the distribution if it is a parametric, all that stuff is something is available to you. Okay, it's a called k density. First install it. I have already installed it, and the function here is the k density. So here we are. Okay, and let's see what's there in KD. All right, so here you have the details of it, the data used, the bandwidth, the kernel used, so all that stuff. It says for the non-parametric part, the algorithm is very similar to the k-means algorithm. So it doesn't fit some sort of a model. It doesn't have estimates. I mean, you cannot reproduce the same estimates without having a seed for the random value, random number. Sorry. Uh, but yeah, so it's not a model. That's something to be remembered. It's a non-parametric way of calculating. Okay, let us plot. Yeah, so when you simply plot the KDE, you also get the same. Okay, the difference is that you have a lot more flexibility here. You can also change how you start, what should be the kernel, the different kernels used, right? Different smoothing parameters also you can choose. You can explore more about this particular package, and depending on the research question, you can then choose. And very importantly, you can also have a parametric density, right? Instead of a non-parametric one. Okay, so here we have just the plot dot start is true. So that's the difference here. And we get a parametric one in that case. You see, so we are now plotting the parametric as well as the non-parametric one. The one which is the red is the parametric one, and the non-parametric one is just plotted against it. Okay, so you see a slight difference here, right? So all these flexibilities are available in this particular package.